Hey guys, Mr Fraser here from Maths Bright Future. Today we are going to look at how we solve inequalities. And I've really only got one question for you. Can you solve algebraic equations? If so, this is going to be easy. The only thing you need to remember is what we do when we divide or multiply by negative numbers. But I'm going to show you how we can avoid doing that altogether. Stay tuned to learn how we solve inequalities.
When I learn, push it out, learn, make it count, learn, get it in, learn, discipline, learn, work it out, learn, write it out, test what you learn, you only get what you got.
Right, so in this question we're asked to solve the inequality 4x minus 7 is greater than 11 take away 2x. How do we go about doing this? Well, it's exactly the same as solving equations. In this case, we've got unknowns on both sides, so all we need to do is collect everything with an unknown on one side, everything else on the other side, all of the constants on the other side, and then solve for x. And that's it. Pretty straightforward, really. Now, if you don't know what I did there, I suggest going and having a look at my solving equations video. But all I've done is used inverse operations, ultimately to solve for x. In questions like this, I think of the inequality sign just as I would as an equal sign. Everything from there is exactly the same. The only time it's not the same is where you are multiplying or dividing by a negative number to get x by itself. Let's have a look at an example like that. Right, so this is a slightly more complicated question, but I'm going to do exactly the same things as I did in the last question. I'm going to use inverse operations to effectively solve for y. I'm going to stop there because this is very, very important. In order for me to get y by itself, I'm going to need to divide both sides of this inequality by negative 3. When we divide by a negative number, we need to remember to flip the inequality around. That's very, very, very important. So my final solution is y is greater than or equal to 2. Now, we can avoid this. We can do it so that we never ever have to remember this rule. How? Well, we could start by collecting the y's on the side where there are the most y's. If we do that, we'll never have to worry about this. Right, so have a look at this. First thing you need to ask yourself, are there more y's on the left-hand side of the equation or the right-hand side of the equation? Well, there are way more y's on the right-hand side of the equation. There are six y's there and only 3 y's over here. So what I'm going to do, I'm going to collect the y's on the right and the numbers on the left. So as you can see, we get exactly the same. The inequality is written the other way around, but it means the same thing. This means that 2 is less than or equal to y, and that means that y is greater than or equal to 2. They mean the same thing. I could just rewrite this inequality as... So, the most important thing that you need to remember is that when you divide by a negative number, you need to flip the inequality around. You can avoid doing that if you collect the unknowns on the side where there are the most unknowns. That'll ensure that you have a positive value and you won't have to divide by a negative value. Right, so an even more complicated question might ask you to solve this inequality. Now, in order to do this, I think the best way of doing it is by doing it in 2 parts. So, first of all, we're going to look at this. 4x plus 5 is less than 3x plus 5, and we're going to solve that inequality. And then we're going to solve this inequality. So we're going to do it in 2 parts. I'm going to use 2 colours. Let's use blue and green. Right, so let's collect it where the most unknowns are. So let's get all of our x's on the left-hand side, all of our numbers on the right-hand side. Right, in this case, I've got more x's on the right hand side, so I'm going to collect my x's over there. Now if I look at these together, x is less than 0 and x is greater than or equal to 2. I couldn't rewrite them as one inequality. Sometimes you can, but these two are separate inequalities. So if these were to be represented on the number line, I'm going to look at this one first. If you don't know what I'm doing here, it would be worth going and looking at my representing inequalities on a number line video. X is less than 0, so I'm going to put a hollow circle at 0. And I'm going to draw an arrow to the left hand side because it represents everything over there. Whereas here, x is greater than or equal to 2. So here I'm going to put a full circle and I'm going to draw an arrow to the right hand side. In many occasions you can rewrite these as one inequality. I can't do it this time. That's it. That's it. That's how we solve inequalities. Pretty straightforward. In most parts, just treat it like an equation. Solve for the unknown. The only time it's not is if you've got a negative coefficient and you need to divide or multiply by a negative number to get rid of that. In which case you need to remember to flip this inequality sign around. But you can avoid that if you want. I hope you found this useful.